So today we are going to discuss about elements of simple curve. So we know that what is simple curve. Simple curve is always drawn between two straight, that is A, V and VP. These are the two straight. So T1 is a point of curve and T2 is a point of tangency. So first element of the curve is length of the curve, which is denoted by L. So length of the curve, that is T1, C, T2, is called as, this curved portion is called length of the curve. So length of the curve is calculated by using formula, that is radius into central angle, that is delta. So L is equal to, length of the curve is always equal to radius into central angle delta. So here delta is in terms of radians. So we have to convert it in terms of degree, because in our laboratory, usually we will use compass theodolite for the calculation of the angle. So angle every time we will get in terms of degree, not in terms of radians. So we have to convert radians into degree. So r into delta into pi by 180. Now it is in terms of degree, because 1 radians is equal to 180 by pi degree. So 1 degree is equal to what? So pi by 180. Now it is in terms of degree. If the curve is designated by degree of the curve, then dA is specified length of S. Then L is equal to R into delta into pi by 180. This is a standard formula you have to remember. So just substitute as per the designation of the curve. So R is equal to S divided by dA into 180 by pi. So S divided by dA into 180 by pi into delta into pi by 180. So L is equal to S into delta divided by dA. When degree of the curve is given, then we should substitute this formula, L is equal to S into delta divided by dA. Suppose if radius is given, then we have to write this formula, L is equal to R into delta into pi by 180. So this is the first elements of the curve. So let's move on to second elements, that is tangent length, that is T. So T is equal to length of T1B and length of T2B. So in this figure, so tangent length is equal to T1B and B T2. That is denoted by capital letter T. So length of T1B is equal to, so here we will take this triangle T1BO. In this triangle, so this is a 90 degree, we want now T1B. Therefore, so this is 90, so this is T1B, and this is delta by 2. Now delta by 2 is touching this, so we can write length of T1B is equal to OT1 into tan delta by 2. We know that tan is equal to T1B divided by OT1. We want T1B. OT1 we know radius. So this can be written as length of T1B is equal to OT1 into tan delta by 2. So OT1 means radius. Substitute that R into tan delta by 2. Therefore T is equal to R into tan delta by 2. So this is a formula to calculate T value. So T is equal to R into tan delta by 2. Next, every time while starting practically, we want starting point chainage. So point T1 is called point of the curve, that is the starting point of the curve T1. So we need chainage. So how to calculate this chainage of T1? So here the chainage of the point of intersection is generally known, because so these two straights are joining at V. So we can find what is the length, total length from T1 to V as well as V to T2, that is same. T1V is equal to V T2. So we can find what is the chainage of point of intersection. If we know this intersection chainage, then we can calculate what is the chainage at point of the curve, that is T1, and what is the chainage at T2. So chainage of T1 is equal to, we can write in this case chainage of V, that is chainage of point of intersection. Now I want to reach this point, so chainage at V minus, so T1V called as tangent length denoted by T. Therefore chainage of T1 is equal to chainage at V minus T1V. You can write T. So here it will be written chainage of V minus T. Similarly, chain edge of T2 is equal to, so now, so this chain edge we know. Now I want to calculate chain edge at last point, that is point of tangency T2. So this can be calculated with the help of chain edge of T1. Again, no need to go for V. It is not possible to calculate from this. So every time you have to calculate chain edge at T2 is equal to chain edge at T1 plus, we know that what is the length of the curve, already we have calculated in the elements. So chain edge at T1 plus length of the curve, it will give chain edge at T2. So here chain edge can be calculated. One is chain edge of T1, that is point of curve, chain edge of point of intersection minus T, and chain edge of T2 is equal to chain edge of T1 plus length of the curve, that is L. So this is a formula to calculate chain edge. This is a third element. Next, fourth element, the length of the long chord. So length of the long chord means in this figure, that is the distance, total distance from T1 to T2. So T1D, T2 is called length of the long chord, that is denoted by capital letter L. So here to calculate that, it is very simple. So L is equal to, we know that, so this is a delta and this is a triangle. So we want now T1T. So this is now opposite side. Therefore we have to apply sine rule. So while applying the sine rule, we will get, so L is equal to 2R sine delta by 2. Why 2R means, because first we are calculating T1D, so R into sine delta by 2. So T1 T2 means that is 2 times. So T1D is equal to T2. So that is 2R into sine delta by 2. So it is not possible to take a delta, because first we will consider this triangle T1D O. Next we will consider T2D. While considering this, so T1D is equal to R into sine delta by 2, and while considering this, again R into sine delta by 2. So adding T1D plus T2, that is 2R sine delta by 2. So that is the formula to calculate length of the long chord, that is L is equal to 2R sine delta by 2. So you have to remember all these formulas. Next, external distance, next element, fifth element, very important. External distance, it is also called apex distance. So that is E is equal to, so here external distance means that is a distance from B to C. This is a external distance. So that can be calculated, external distance can be calculated. So length of BC, that can be written as VO minus CO. So length of the curve is VO minus CO. So we will get this CV, length of the curve CV. So next, so length VO means here R secant delta by 2, and CO means that is the length of the curve. So VO means we are considering this triangle. So again we are applying cosine rule. So touching to this, so this is a 90 degree. We want now OV. So while calculating OV, we will get this OV distance is equal to R into secant delta by 2. And OC means, so touching to the length of the curve. So this is considered as T1O, OC and OT2. All these are radius of the curve. Therefore, this can be written as, so external distance is equal to R into secant delta by 2 minus R. So external distance R is common, take outside. So secant delta by 2 minus 1. So this is written as E is equal to R into X secant delta by 2. So this is the formula to calculate external distance. Next one, mid-ordinate M. So mid-ordinate M means here that is CD. So this is called mid-ordinate. CD is called mid-ordinate. So already I have explained in previous video. So mid-ordinate CD can be written as, here this can be written as CO minus DO. So CD can be written as OC minus OD. So OC means already we know that is a radius, and OD means here, that is while considering this triangle, now you can see this is a delta by 2. So here this is a 90 degree. So this can be written as, OD can be written as here that is r into cos delta by 2. So r into cos delta by 2 OD. So this is the opposite side and this is the adjacent side. So adjacent side always we will take cos and opposite side we will take sine. So OD is equal to r into cos delta by 2. Therefore, so mid ordinate is equal to m is equal to r into 1 minus cos delta by 2. So 1 minus cos delta by 2 is equal to r into vers sine delta by